Today is November 20th and we are solving by the square root method. This, again, is one of my favorite topics to cover. And I know that I say that a lot, but quadratics in that whole unit is one of my favorites. And then once we get to inverses, that's one of my favorites as well. So, solving quadratics by the square root method. Quadratic equations of the form x squared equals n can be solved using the square root property. So if x squared equals n, then x equals the positive and negative square root of n. So remember when we take the square root of a number, we found out that we have to take both the positive and the negative because we got minus 2 times minus 2 gives me positive 4. So we do have to take the positive and the negative. So we have to use a plus or minus, and we'll take the square root of both sides. So we're going to solve each of these using the square root method. On number 1, it is not of that form x squared equals n. I have x squared minus 64. So to use the square root method, I'm going to move this 64 to the other side by adding 64. And I get x squared equals 64. I'm going to take the square root of both sides. Let me use a different color. And so x equals, and the square root of 64 is 8, so plus or minus 8, and that's it. So this is one of the simpler ways to solve, but it has to be of that form where x squared equals a number. If there is more terms than that, we cannot use this method. On number 2, 7x squared plus 8 equals 15. So first thing I want to do is move that 8 over. I get 7x squared equals 7. But I can't take the square root of 7. What I can do is divide everything by 7. So that way I get x squared equals 1. Now I have it of that form x squared equals n. So I'm going to take the square root of both sides. And x equals plus or minus 1. Now on number 3, 81x squared plus 5 equals 21. I see that there's not a bx term. There's not that middle term. So since that's not there, then I know that I can use the square root method. So I'm going to move the 5 over. I get 81x squared equals 21 minus 5, 16. I can take the square root of both sides, but let me see if I can take out a GCF first. So before you start to try to take the square root, see if there's a GCF. There is not a GCF between 81 and 16, so I'm going to take the square root of both. And I get 9x equals 4. But I still need to get x by itself with this plus or minus. So I'll divide by 9. And I get x equals plus or minus 4/9. So this even works when we have fractions involved. Now on number 4, 8x squared plus 1 equals 17. I'll subtract 1. And I get 8x squared equals 16. They do have a GCF, which is 8. So I'll divide both sides by 8. And I get x squared equals 8. Oh, sorry. X squared equals 2. And then I have that of that form. So I can take the square root of both sides. And I get x equals plus or minus the square root of 2. So it won't always be a perfect square root. We see that we got a fraction, and we also see that we got the square root of 2. So just be aware that it won't always be a perfect clean number. So then on 5, we have 2x squared minus 9 equals 55. I'm going to add 9 to both sides. 2x squared equals 64. I have a GCF, so I'll divide both by 2. I get x squared equals 64 divided by 2 is 36. No, it is not. It's 32. That's what happens when you try to do math in your head too quickly. And we'll take the square root on both sides. So we get x is equal to plus or minus the square root of 32. Now when we do large numbers in there, we want to simplify the radical. It says that right up here. So I can simplify the square root of 32. So I have 32 is 2 times 16, which is 2 times 8, which is 2 times 4, which is 2 times 2. So 32 is 2 to the 5th power. I have one pair of 2's, another pair of 2's, and then this 2 that's left over by itself. So x equals plus or minus 4 square root of 2. Then on number 6, 9x squared plus 3 is equal to 111. We'll subtract 3 first. 9x squared equals 111 minus 3 is 108. We'll divide by 9. We get 12. So x squared equals 12. And then we do have to take the square root of both sides. X equals plus or minus the square root of 12. That's a large number on the inside, so we'll see if we can simplify. 12 is 2 times 6, which is 2 times 3. That's as many times we can go to get all prime numbers. There's one pair of 2's and then a 3 left over. So x equals plus or minus 2 square root of 3. And then we're done there. So that is it for the notes for today. And then you will have the homework on the right side. Make sure that you are having the numbers on the left side. So x squared or whatever your variable squared equals a number, and then you can use the square root method. I will be posting half of these answers on Canvas, so just check back to see if your work is correct and if you did the problems correctly.